Login accepted.
Okay, everyone, so hi. Oh, okay. Hi and welcome. Today we are looking at opening the packet with Cisco Packet Tracer. So today is the 24th. Become a member, sign up for Hivestorm. This is another competition. Registration ends on the 30th, so that date is coming up. And then, hi everyone, my name is Rachel DeCastro. I am a CIS student, a senior. I am the current director of infrastructure, and I'm also on Cyberforce. So today we're going to be looking at networking, which is a very fundamental and very foundational part to cybersecurity. If you don't understand at least some of the fundamentals of networking, you can't really build a house without the foundation, or tear down a house if there isn't one to begin with. So today we're going to be looking through various topics. It'll be a lot, but I promise you, even the more abstract fundamentals will all come together once we start to actually look at Packet Tracer and get to actually start playing with the equipment. So we're going to start by going through the OSI and TCP/IP model, which are important layers in the network engineering sector. And they're also really fundamental if you're going to start looking into ethical hacking or red teaming or defending infrastructure. And there's also something called a header, which will make a lot more sense that we'll see later on when you start diagnosing your equipment, for example. And we also go through really fundamental and important processes called encapsulation and de-encapsulation. And we'll finally get a preview on Friday. So firstly, with the OSI and TCP/IP model. So ogres are like onions, as to networks are the ogre, essentially. They have layers. And for the context of this, when we get down to it, it can be a little complicated to conceptualize because there's so many different ways people want to explain this. And even the Department of Defense has their own way. And personally, I like the 5-layer TCP/IP model, but basically they're all the same model. It's just they are squished down in different ways. You have layers 1 through 7, and in the OSI model, you have all 7 layers. In the 4-layer TCP/IP model, you squish down application, presentation, and session, which are all more software-focused layers, into one just called application. And then you also, in that model, you squish down the data link and physical layers into one layer called the link. And then the 5-layer TCP/IP model is essentially if the OSI model and the 4-layer TCP/IP model had a baby. And if you are ever planning on taking the CCNA sometime in the near future, this is also the model that's currently being taught. So as you see, there's a lot of different layer combinations. And in this one, for example, I split it up 4, 5 through 7. And that basically is how it's presented to the end user. So you have the application, presentation, and session. And like I said earlier, those are the layers mostly used by software developers. So we are, for this particular presentation, we're not going to really look at it all that much. But you also have something called PDUs, which is another important concept. And that's short for Protocol Data Unit. And a protocol data unit is a specific type of way to describe a certain unit of data specific to that layer. So for example, through 5 through 7, we just have data. In layer 4, we have segments. In layer 3, we have packets. In layer 2, we have frames. And then in layer 1, we have bits. And to get a little bit more specific with the examples, layer 4 is transportation. Layer 3 is the network, which is going to be our particular focus, but also we'll look at 4, 3, and 2 just in general. And layer 2, we have the data link. In layer 1, we have physical. And layer 1 will be the easiest to conceptualize because that's our Ethernet cables, the electricity itself. So if you've ever seen binary before, stuff like that, essentially. And then also, if you are attempting to try to memorize these layers, good for you on that. But also a good acronym that people like to remember it is all people seem to need data processing, which is APSTNDP. So when we go down, we can see actual versions or actual protocols and such for each layer. So we have, for example, we have the actual web browser that we see on the application layer. We have the presentation layer, which is how it is actually presented to the user. We have the session, which is how long it's established for, and that goes down if, for example, you close out of the session. We have the transportation, which is how the data goes across the network, essentially. We have the network itself, which, if you know IP addresses, that's where that lies. We have Ethernet, which is, for example, MAC addresses sit in there. And we have, once again, the physical layer, which is the actual cabling. So now we have encapsulation. I'm going to go through this briefly because we'll go more into it later when you have more context. But essentially, the process of encapsulation is, if you think of a pill, you put the medicine in the pill, and that is essentially going to get sent out. And then when it goes through your body as the receiver, it gets de-encapsulated throughout your body. And in encapsulation, you have data that slowly gets encapsulated. Layers 5 through 7, it's just data. And then when it gets to layer 4, 3, 2, 1, it gets more and more encapsulated as it goes through. And then, so now, as I briefly mentioned, we have layers 2 through 4, which will be a target of our focus. And this is because these layers are the important ones to our field. And if we were software engineers or developers, or if there are any of you in here, your focus would be through those layers because that's where software processes live. So when you refer to your IP address, you're normally thinking about your IPv4 address. Both of those addresses are on layer 3, but really quickly, I'm going to tell you a little bit of history with IPv6 and why it exists. So once upon a time, essentially, the creators of the internet decided to give computers addresses. However, when they were computing how many addresses that they needed, they only created 4.3 billion, which it sounds like a lot, but then it also, when you think about it more, it's not really all that much. Only 4.3 billion. But surely there are, more than 4.3 billion computers in the world right now. Present day, it's a crazy amount to think about. Unfortunately, the creators of the internet, when they were inventing it, did not take that into account about the explosion of technology. But who else would have expected that? Who can blame them? So to remediate this, they created something called IPv6. And so now let me ask you a funny question. Do you like the brown parts of your Lucky Charms? Or do you just eat the fun sugary parts that have, So to many people, letters in their IP addresses are the same way. So even though, they don't like the big ugly string, they kind of would rather just eat the sugary parts of their Lucky Charms similarly. Even though they don't have enough IPv4 addresses, they would rather use that. They don't like numbers and letters being mixed together into one big string. I mean, like, look at this. That does not look fun. So it's a hard pill to swallow, but eventually we will have to move to IPv6 because it can house 340 trillion. That's 3 sets of trillion. So, which means that is 340 undecillion addresses. And I have no clue what an unda is, but that's like a big number. So now we head up to layer 4 with the TCP and UDP protocols. And TCP might sound familiar because in the TCP/IP model that we looked at earlier, this is a foundational topic to networking. It enables a large amount of networking across the internet for communication. And it's one of the first and most important suites ever created. So TCP uses something called a three-way handshake, which essentially confirms that your traffic gets safely to its destination. When you connect to something, you attempt to synchronize with it. Your destination confirms it with something called a synchronization acknowledgement. And then once that destination, or once you find your destination has acknowledged your synchronization, you acknowledge that it had done that. So now, yay, your connection is established, and it confirms that your connection has properly, been established. So if anything goes wrong along data being sent that way, it gets appropriately handled. So for example, if your data gets lost, it gets resent out through the network again. So do you guys have any particular mail like company that you don't like, UPS or, American? So basically, if you think about UDP, that is that company that you dislike for losing your package because it says, oh, well, I did my job. You didn't get it. Too bad. So another way to be more familiar with these are MAC addresses. MAC addresses are layer 2 on the other hand, and MAC stands for Media Access Control. And you may have heard of it before. A MAC address is essentially, it's physically etched into your hardware. If you have a network interface card in your computer, you will see that your MAC address does not change like your IP address. There's a larger amount of them out there, so we don't have to worry about running out of MAC addresses like we do IP addresses. But if you ever go to study something like the Sec Plus, for example, you'll learn quickly that that also can be spoofed. So now we also have something called ARP, which is short for Address Resolution Protocol, and it essentially acts like a satellite. So say you want to deliver mail to someone, but you don't know their address. How would you go about figuring that out? You would probably pull out like Google or Apple Maps, right? So maps and GPS software utilize satellites to map things out so they know where they are. In ARP, it uses something called a broadcast, which essentially is a frame that gets sent out to every interface except the one that it received it from. So when someone sees their address is trying to be found out, they respond by saying, hey, that's my address. And then it sends it back so that it can get mapped into something called an ARP table. So now we're going to go through the actual encapsulation process. And it's going to be a lot, but I'm going to try to use a lot of comparisons with mail to this. So for this, imagine that you're trying to send your friends some sort of mail. And in this context, let's say you live in an apartment building. So when you want to send someone mail, you write the mail, have whatever mail you want, and then you fold it up into an envelope. And on the envelope, what do you write? You write their address. And that's basically encapsulation. So for more context, routers are layer 3 devices. They don't know layer 2. And we also have switches, which are layer 2 devices, and they don't know layer 3. And for our comparison, we will say that the switch is our apartment's mail sorting room. And then the router is the post office. So essentially, so remember that layers 5 through 7 are data without further encapsulation. So we're going to go straight to layer 4. So as data gets ready to be sent out, you fold your data into the envelope again. So instead of just writing an address, more specifically, we're going to fold up what's, in our context, the segment mail into a packet envelope. And then you send that out. The next, say the post office picks up that mail. The post office doesn't exactly know how to send to the destination yet. It sends it to the next post office. So what it does is it folds up that packet mail into a frame envelope. And then going down along the encapsulation process, you fold up the frame mail into the bit envelope. And that's when it gets ready to go over the wire, essentially, to its destination. So when we receive the mail, we can go in reverse, essentially. So as the data gets forwarded to its destination, it'll slowly start to peel off the layers of the outer envelope to check if the receiver recognizes the address inside the envelope until it eventually reaches the destination. You unfold your frame mail to check your envelope essentially again. And if the address is something you recognize, you pass it along onto the next network that you see that it's to. And you unfold the packet mail to check the segment envelope. If it's where it needs to be, you pass it along to the receiver again, reading the TCP UDP contents. But we have a scenario, say for example, that if a router finds the packet and sees that it doesn't recognize the address inside of it, what it does is it re-encapsulates it, so it puts it into another envelope, and then sends it along to who it thinks it knows where it belongs to. So for example, we have Bob and we have Jill. So Bob doesn't know someone, but he thinks that Jill knows someone. So Bob will give it to Jill because Jill will know who it is for and then give it to them. So, and then this is essentially the process of what I just explained happening. As you see, every single version, this is the mail, for example, it gets put into another envelope, and when it gets put into an envelope, it gets a header, which is essentially the envelope itself. And then it gets put into another envelope when it gets the IP header, and then it gets another envelope, and then it gets the Ethernet header. So this information, it tells it where it needs to go essentially and who to forward it to, because different networking devices need to know different parts of information. So then it gets sent over. This green arrow is essentially your Ethernet cable, for example. It gets sent along the wire, and then as it gets to the destination, say for example, the receiving post office, then it starts to slowly peel off those envelopes until it eventually gets to its destination. Oh, and there's also something called a next hop, which is essentially, in my analogy of Bob and Jill, that is essentially, Jill is Bob's quote unquote next hop, or the next person it refers to when it doesn't know something. So now we're going to Mac and IPv4 header fields. And so this, it seems like a lot of information, but when we start actually going into more packet tracer, it'll start to be something you can actually look at, and then you can see if something goes wrong in your network, you can actually refer to these fields and then see what exactly went wrong. So we have various fields. A lot of them are self-explanatory, sometimes not so much. We have the version, which specifies whether the address is IPv4 or IPv6. So sometimes if say your traffic gets stuck because it's IPv6 and you look on your version, you'll notice, hey, this isn't what I meant to send. I meant to send an IPv4 address. We have the internet header length, which specifies the total length of the header. We have the type of service. Well, as you can see, it specifies the type of service. We have the total length, which specifies the total length of the packet. We have the identification, which specifies which fragment belongs to which packet if the packet's too big and needs to be fragmented into pieces. So it essentially tags each fragment, so it knows who it essentially belongs to, like a puzzle piece. And then for more of that, we also have the flag field, which specifies information about the flag fragmentation, like I mentioned earlier. We have the time to live, and even though that sounds dramatic, the time to live is quite literally how long it has to live until it dies. So essentially, it specifies how much it can exist before it expires, more specifically. And this prevents the traffic from infinitely looping around the network and just essentially getting lost, because otherwise that would create a lot of traffic if we just had infinite looping packets sitting everywhere. So we also have the protocol, which specifies if it's TCP, UDP, ICMP, OSPF. We have the header checksum, which checks for errors on the packet, the source and destination addresses, which are, like I said in my mail analogy, those are the actual to and from. And then we have the options, which are rarely used, so we're not going to focus too much on them, but essentially it increases the header length if it exists. So then we also have the header frame fields. This one's a little bit smaller, but it also specifies a lot of important information about the MAC address, for example. We have the preamble, which we use for synchronizing your network information. We have the start frame delimiter, which prepares the device to receive the rest of the frame. We have the source and destination, which again, it specifies the to and from part of it. We have the type, which specifies the layer 3 protocol that was used in order to encapsulate the packet in the first place when it turned into a frame. And we have the frame check sequence, which uses something called CRC, which stands for cyclic redundancy check, which is essentially, in fancy terms, it's a mathematical algorithm that checks for corruption. And then now we are going to actually start preparing for packet tracer. So what is packet tracer? Why are we talking about it? So packet tracer is essentially a visual network simulation tool used to create and test network environments. It's extremely realistic. You can even click on your devices and see what the hardware would actually look like. You can literally see the ports. You can put in modules to your switches. And essentially, even it goes as far as to show how long it would take two machines to sync up as if you were to physically connect them to a wire, the exact same amount of time. So like 15 seconds for it to synchronize. And I know a lot of you look into IT not only to get the fundamental topic of cybersecurity, but some of you don't even want to go into the hardware side. So that's what this is great for. Sometimes you don't have the space, you don't have the money or the knowledge to buy the required equipment for your labs, but that's another place where Packet Tracer can come in handy because you can play around with your different types of wires even with your network setup. So some essential parts of Packet Tracer, we will go a little bit more on this on the workshop. We have different command modes. So we have the user exec mode, which is basic monitoring commands that you can use. But if you set, for example, a password, you can't do anything besides just monitor configurations on your switch or on your router. You have a privilege exec mode, which gives you higher level of access, which is what you log into when you go past exec mode. For example, in the picture, we see that you have to type enable in order to get to that mode. We have also the global configuration mode, which is for your most important and more specific configurations. So for example, if you have a local area network set to a certain port on one of the devices, you have to go into your global configuration mode in order to make changes about that specific local area network. And another tip too, and this is probably better for when you understand it a little bit more, but you can actually prepend the word do to any of your commands when you're in configuration mode to do, for example, privilege exec mode commands from your global configuration mode. And then one of the last topics we'll go over today for Packet Tracer to give you a little bit of an understanding, we have something called real-time mode and simulation mode. This is Cyberpunk Edge Runners, if any of you watch that. It's essentially, I'm trying to show that when you're in simulation mode, everything acts kind of like a slideshow, and there's different frames of time that you can essentially go through and analyze each. Versus real-time mode is just the regular kind of mode that things would look like if you were actually doing it in real time, in person, with actual real equipment. I was also gonna use JoJo's for this, but I wasn't sure which one's better. And then so now we're gonna go through a mini demo. Oh, actually, before I do that, sorry. I'm gonna give you guys some time to download this. I also have it here while I go through the mini demo. So if you guys haven't already, please download this for the Friday workshop so that we can get started. We're not gonna be using any VMs this week. And then for the actual mini. Okay, so this is Cisco Packet Tracer, and I am essentially going to show you how to set up a more basic type of network. So, like I said earlier, we have our physical pieces of equipment that we can play with. So for example, I can put down a switch if I wanted to. I could put down, oh, that's a router, my bad. A switch if I wanted to. This is actually a switch. I could put down PCs, servers, laptops, any type of other kind of client-side equipment. So I'm going to put down a PC for this example. And then I am going to do so again for the other side. And then now I'm going to actually connect these together as if I was in an actual lab environment and I was connecting these devices together. So we're going to connect these together. So you can even see it goes as specific as the different ports. And if I were to open this further, we can actually look at the actual back of the equipment and see what it looks like. You could even put different modules in. And then I'm going to connect more devices together. This requires a different type of cable, so I need to use a different type. So it even goes as deep as to showing you what kind of cables work and don't work. So if I were to use the wrong types of cables together, it physically would not work. So now I can actually go into each device. I'll start with the router, for example. How do I get this out of the way? There we go. So I can actually go into the command line interface this is for the router. And then I can go, let me put this down. I can actually configure, for example, so this interface right here, this is F01. So I can actually go into that interface just like I would a real switch. Oops. Am I on the wrong device? I am on the wrong device. Router, okay. So we're actually going to go into G000. So now we're in the configuration mode, like I mentioned earlier, for this actual device, and then we can assign it an IP address. So I'm going to call this 192.168.1.1 because that's the router. Oops, I need the subnet. And then, so now you'll see, or in a bit, you will see that change when I configure more of it. And then I can do the same thing. And then this one's name is also G001. And this will make a lot more sense once you actually start to get to play with it. And then I will also give this one an IP address, for example, 192.168.2.1. I keep forgetting the subnet. Okay. And then we can go into, for example, these two devices, we can give them IP addresses as well. So a default gateway is another term for a router. So essentially, if I want to point one of these devices to the router, I would just put in that device's IP address, 1.1, because that's what we named it. And then I'm going to give this one an IP address of this. I can choose whichever I'd like. And then when you start to learn more about subnetting, this will also get something where you could play around with it more as well. So I named that one that, and then I'm going to give this one an IP address of this. And then now I just need to connect these two routers together. Change the interface. So now I'm going to change these two interfaces. And then IP address, I'm going to give this one the IP address of 192.168. Let's do 3.1 for this one. I just, again, forgot about subnet. Subnet is another big part of networking that you don't need to go too in depth for to understand, but for the sake of this, we're just going to use a very basic subnet. Everyone tends to like 255.255.255.0 because it's simple and it just works a lot of the time. Let me make sure I'm using the right interface. I am. And then I'm going to give it the IP address of 192.168.3.2. And then, so now if we wanted to check something and say, for example, that this isn't gonna work, I could go into, so these are the actual interfaces for the computer, for example. So I can go into my computer's command prompts, and then, for example, I can ping something. I can't see what. Oh. May change that. So let me go back to that other pop-up. Which one? Good now, okay. Sorry about that. So now you guys can see this pop up. This is what I was mentioning for your actual applications. So I'm gonna go into the command prompt of my PC now, and then I can ping 168 . So this device's IP was 1.2. And then so what I can do, say if I'm diagnosing my equipment, I can go into simulation mode and it'll essentially slow down time so I can see everything that's happening instead of just typed ping twice. Instead of just simply seeing whether or not it works. I can actually go and into analysis mode essentially. So now nothing is happening yet because I essentially froze time. And then I can go through the specific frames. You see, that's the literal like data moving across the wire, going to the switch. And if I wanted to, say for example, I'm gonna move it here. I'll go back. I could actually go here to the simulation panel, and I can actually look at the information. So for example, when we looked at the Ethernet frame, for example, earlier, not only do we actually get like the steps, but we can actually go and see the exact fields that we saw earlier in the slides. So this is the exact same thing, the exact same fields up here in the Ethernet header fields. So we got the preamble like we saw earlier, we saw the start frame delimiter, we saw the address, we saw the source, and essentially anything that goes wrong, we can actually see in depth of what happened. So now that you guys have had some time to see what it looks like, let me go back to the link. And then now we can actually give you guys a shot to download it, and you guys can play with this for the next few days, or you can wait until the workshop when we can actually help you if you get stuck on anything. And yeah, that is essentially the packet tracer workshop. So yeah, thank you.
They don't have questions.
What are the resources you use to learn more about how to use the Cisco?
So me personally, I have been studying through the CCNA, and that gives a lot of networking fundamentals and information. But you can also use Packet Tracer itself to learn these fundamentals. If things get too hard, there's plenty of free labs that you can use online and download, go through Reddit pages, or you can use the lab that we will use on Friday to essentially learn more about those networking fundamentals. But yeah, me personally, I use CCNA. Any other questions? No, I think we're good. So yeah, take some time to download this, and yep. Is the recording stopped?